Chapter 4, Section 3 for precalc. So we're going to evaluate trig functions of acute angles and use fundamental trig identities. If you understood the 4.1 and 4.2 videos, a lot of this should be familiar or seem pretty repetitive. So it's some good review. So let's first warm up by finding the 6 trig functions for this triangle, this right triangle. So if we're giving a leg here of 2, a hypotenuse of 4, we are not given the other side. So the first thing we need to do is find this side. And so using Pythagorean theorem, if I call this x, we can find that. So we're doing 4 squared equals 2 squared plus x squared. So we have 16 minus 4, so we have 12 equals x squared. And we square root both sides and rationalize this, you get 2 root 3. So this side here is 2 root 3. So this is not on the unit circle because our hypotenuse is not 1, but now we have our links. So for the sine of A, and that's the angle given. This is the angle given. We need to know our angle to write our ratios. Sine is opposite over hypotenuse. And so if you need to label this, if this is our angle A, this is opposite, it should be the hypotenuse. So it's opposite the 90, then this is the adjacent. That might help you out as well. Then reduce your fraction so we get 1/2. Cosine of A is going to be the adjacent over hypotenuse. So we have 2 root 3 over 4, which reduces to root 3 over 2. And then we have tangent of A, which is opposite over adjacent, 2 over 2 root 3, which is 1 over root 3, which is the same thing as root 3 over 3 if you rationalize that. And we also have our reciprocal. So we have cosecant of A, which is just the reciprocal of sine, so we get 2. Then we have secant, which is the reciprocal of cosine, so we're going to get 2 over root 3, which ends up being 2 root 3 over 3. And then we have the cotangent A, which ends up being root 3 if you do reciprocal. And I would choose to do reciprocal of this fraction here. So those are the 6 trig functions, and you should realize what angle A is. Thinking backwards, it has a sine of 1/2, a cosine of root 3 over 2, tangent of root 3 over 3. Those should be familiar. We should see that the A is the 30 degrees, or know that. You know you're starting to get familiar with the unit circle. And so goes right along with this. You should be able to find these trig functions, these trig values for these angles quickly. So you should not use a calculator. If you need to draw out the unit circle or the right triangles to create this, you can. But you should know these mentally pretty quick at this point. So this is part 1 of your homework video problem. So homework video problem, question 1 of 2 for tonight. So identities. So we're going to look at these identities. We're going to use these identities for the rest of this chapter and really a year. I'm going to pull it a few times. The reciprocal, we've already done that, where the sine is 1 over cosecant. So those are equivalent values. And so you can go through the 6 trig functions and you can write them in their reciprocal form. We have the quotient, which is talking about how the tangent, we've known the tangent as, if you look at a right triangle, their angle as the opposite over the adjacent. But if you're thinking about the unit circle, this is usually y and this is usually x. So it's like y over x, which is our sine over cosine. And so tangent is sine over cosine, and cotangent is cosine over sine. So these are the quotient properties, so those are equivalent. You can write them either way. The Pythagorean identities is sine squared plus cosine squared equals 1. And this is one of the biggest ones we're going to use here. And this will pop up a few times in later chapters in the year. This is one you need to know. Sine squared plus cosine squared equals 1. And when we write like sine squared t, it really means the sine t being squared. But we write that as the sine squared t. That's the notation we write. It still means the trig function is being squared. We have 2 other Pythagorean identities, which we have 1 plus tangent squared t equals secant squared t, and 1 plus cotangent squared t equals cosecant squared t. And we'll verify these later on in chapter 5 when we start looking at more of our proofs. But a quick one to look at this here is looking at our fractions. Tangent squared is really the sine squared t over cosine squared t if I put it in quotient form. And secant, if I do that in reciprocal, is 1 over cosine squared t. So you look at that, they both have cosine in the denominator. So that's the relationship between the tangent and secant. They have the same denominator. And same thing with cotangent and cosecant, they both have the sine in the denominator. So you can see some similarities in there to help you know those or be familiar with them. So those are trig identities you need to be aware of and familiar with. Given the sine of b is 0.8, we can then find the cosine of b. And there are a few ways to do that. One way is using the identity sine squared b plus cosine squared b equals 1. So if we're trying to find cosine, we can plug in what we know here. We know the sine is 0.8. If we square that, we can then solve for cosine. And so this is 0.64. So I'm going to subtract that to both. So then I'm going to get cosine squared b equals 1 minus 0.64 is 0.36. So I can square root both sides, and I'll find that cosine of b is 0.6. And so we can use our sine and cosine values to answer the next part, knowing that the sine is 0.8 and the cosine is 0.6. Tangent is equal to the sine of b over cosine of b, and so it's going to be 0.8 over 0.6, which is going to be the same thing as 4/3 if you reduce that. And so we have our sine, cosine, and tangent. Another way to do that is think about how sine is 8/10, which is 4/5, and then you can draw the right triangle knowing the sine is opposite over hypotenuse. Then you should know your 3, 4, 5 triangle, and so your cosine has to be 3 over 5 and your tangent has to be 4 over 3. So that could be a fast way of even doing the problem, but I like to show using the identity. So if we know the tangent, another problem here, if we know the tangent of q is 2, the cotangent of q should be an easy problem, it's just a reciprocal 1/2. So we need to recall that 1 plus the tangent squared q is equal to the secant squared q. And so now we can plug in what we know. We know the tangent's 2. So this is going to be 1 plus 2 squared, or 4, equals secant squared q. So this is 5, so we'll square root both sides, and you'll get the square root of 5 is equal to the secant of q. Some of the next examples are basically just proving or verifying. Now, when we verify, we can't be messing with both sides. What we're trying to do is take one of the two sides and manipulate it using identities to become equivalent to the other side. So for this problem, I would start with the left-hand side. Now, if someone wants to start with the right, they can do that. It still works out. But I tend to like to follow the math here, so we're going to try to add these. And to add fractions, we have to have common denominators. So I'm going to multiply this fraction by sine t over sine t, and multiply this fraction by cosine t over cosine t. So when we add these fractions, our common denominator is sine t cosine t. And our numerators, we have the sine squared t plus the cosine squared t. And this still equals, we're trying to hope it equals or show that it equals cosine t secant t. Now, the hard thing about these verifying and proving is that you have to see the identities within the problem. So sine squared t plus cosine squared is the identity, the Pythagorean identity. That's just 1. And so we have 1 over sine t cosine t equals cosecant t secant t. And then we can rewrite this as two fractions. You can write it as 1 over sine t times 1 over cosine t equals cosecant t secant t. And then 1 over sine t is cosecant, and 1 over cosine is secant. And so now they are equivalent. And you do need to show this last step, showing that the two sides are equivalent. That's kind of the roadmap. So that's the whole point of verifying, is showing the roadmap of how two sides are equivalent. So let's do another one. So for this one, and again, you can choose which side to work from. I would choose to work from the right-hand side here. So I'm going to leave the left-hand side. The right-hand side, 1 over sine squared t is cosecant squared t minus 1. Now, here's a tough one, because the property is 1 plus cotangent squared t equals cosecant squared t. So then you need to realize that cotangent squared t is equal to cosecant squared t minus 1. You subtract 1 on both sides. So this is also true. So then we should know that this right here is cotangent squared t. And so then we're done. So it's a quicker one if you can see this property is equivalent, the Pythagorean identities. Solve some application problems. So if we're looking at this river here, so we have water here, and we're trying to figure out what the width of the river is. So we know we have 70 feet of riverbank here, and we know this angle here is 54. And so when you actually do this standing on this side of the river, you can get an angle. If you see there's a tree over here, and then you can get the angle from where you're standing down the riverbank. So the tree is 54, and you're 70 feet away from a perpendicular distance. And so in this triangle, when you do this problem, you need to figure out what your angle is. You label your angle. So then we need to label the opposite, hypotenuse, and adjacent sides. And when we do this problem, we want to figure out what side do you know. So we know the adjacent. What side are you trying to find? We're trying to find the opposite. So you need to figure out, for SOHCAHTOA, which one of these uses the opposite and adjacent, and that's our tangent. So to write it, it's tangent of our angle, 54 degrees. So the tangent 54 equals the opposite, which is W, over the adjacent, which is 70. And so you can multiply both sides by 70 to solve for W. And so you have 70 times the tangent of 54 equals W. This is something you're going to plug in your calculator to evaluate. And if you do that, you get 96.3 feet is the length of that, or the width of that river. I'm going to have you do this one for number 2. This is homework number 2, video homework, video problem. So similar setup. You need to figure out what your sides are, what sides you have are given, find the trig ratio, and then solve the trig ratio. Evaluate. There's 2 problems here. This is problem 1 here. This is problem 2 here. I'm going to go over with you. Evaluating secant 62 degrees. I want to make sure you understand, when you plug this in your calculator, you can't plug in secant. We don't have that key, and it's not cosine negative 1. That's not correct. You have to realize that cosine, or secant of 62 degrees is equal to 1 over the cosine of 62 degrees. So to find this in the calculator, you actually do 1 divide by parenthesis cosine of 62 degrees in the calculator. And so how to punch that in the calculator, I want to go over that briefly to evaluate the reciprocal functions. And then the last problem here, if we're given the angle 60 degrees, then we know this is the opposite, this is the adjacent, and this is the hypotenuse. And we want to know how tall this building is, x, the ladder, how high up the ladder goes. And so we want to use the opposite and hypotenuse, which is actually sine. So the sine of 60 degrees is equal to the x value over 10. And so I multiply both sides by 10. And sometimes we get these special right triangles. The sine of 60, we should realize that that is root 3 over 2. So then we can reduce this to get 5 root 3 as the exact value, how many feet that ladder would be up. So not very far. That is it for the night, so we'll call it good. We'll see you tomorrow.